Hello dear participants, welcome to a new tutorial from Logi Owl presented by me, Joseph, and my dad, Sami Khiami.
Hello everybody, welcome again. Our session for today will be regarding how to control a motor using Raspberry Pi and Scratch. And for that purpose, we are going to use an example for electronic gate that we are going to control through Raspberry Pi and Scratch. So the main purpose is to end with a motor that will control the gate, and we will be able through Scratch to write the program to open the gate and close the gate based on a password. And I will move directly to show you the final implementation of that project. Then we will go back to the details. Moving here now to show you the full implementation for our sample. So our implementation will depend on a motor. This is a motor that I got from an old toy, and this motor is attached to an arm. So this will represent a gate arm that will close the gate or open the gate based on the movement of that motor. So my application is just to be able to use Scratch to ask about the password. So if the password is okay, the gate will be opened automatically and will stay opened for 8 seconds, then it will close again. If the password is not okay, I will get a message that your password is not okay and you are not authorized to access. And then we will see after all the details of how this is working. So I will start with putting bad password. This is the Scratch, and I will use bad password, any bad password test. And when I click on the bad password, I will get password is wrong. You are not authorized to pass. Okay, and the character here will ask me again, what is the password? And now I will use the right password, and I'll use my right password here is Sami. So I'll put Sami and click OK. As you see, we controlled the gate and we opened it and closed it as we like, depending on rules that we set in our program. So moving back to see how we did all the wiring, everything to end with the that result. The first step is trying to access my Raspberry Pi. I'm using the VNC virtual network computing to be able to access it remotely. You can, if you are using your Pi with the screen and keyboard and mouse, you can access it locally and do the development on it. So I'm going directly onto my Pi and opening that. Going to Scratch, I'll be using Scratch version 1.4, which is that one. Okay, the first step for me is to understand exactly what I'm going to end with, and as I showed in the implementation for the gate, so we showed that first there will be a question about what's your password. If the password is okay, so the gate will open and will stay open for 8 seconds, then it will close. Otherwise, you will get the message that your password is wrong and you are not authorized to access. So the first step is to be able to create the logic of checking the password. So first thing that we are going to do is going directly to the control and adding that when you click the green flag. Then from that to add like the check, this if else thing, and this if else check will be repeated forever. So with each new person trying to pass the gate, we will be having that. So I will put that inside a forever block. Okay, so what will happen if the password is okay, and what will happen if the password is wrong? First, let's check where to get the password from and how to check if it matches the password that we have. So I will use the sensing to go and ask. This is the block responsible of asking, so I can add it before the check. So ask, and the question will be what is the password? And based on that, the user will be answering, and the answer can be checked through an operator. So we go to the operator, and we have those comparisons in the operator, and the comparison that we are interested in is like the equal. So if the password, which is the answer, and we can get that from the sensing also, and we can drag the answer to that part here. So if the answer equal, and my preferred password is Sami in that case. So if the answer equal Sami, do something. If not, do something else. Okay. So if password is Sami, so I will go to looks and send a message with waiting. So I will say the password is okay, maybe for 1 second. Welcome, password is okay. If not, I will say sorry. I'm using say and wait, so I will be waiting for 2 seconds. Here I will be waiting only for 1 second because there's lots of other things that will be shown after that. So say hello, say bad password, you are not authorized to pass. Okay, so bad password, you are not authorized to pass. And I'll be waiting here for maybe 4 seconds. Then it will ask the question again because the loop is forever. Okay, now if the answer is true, like Sami, like answer equals Sami, so the password is okay, I need to do things to open the gate. Now, before doing anything related to the controlling the Raspberry Pi, I need to control the GPIO port. So the first thing that I will do to control the GPIO port is to add a broadcast to be able to open or to turn the server, the GPIO server on. So I will add a broadcast. And this broadcast does not have to be like, it will be one time only, so it will not be inside that loop. So broadcast GPIO server on. Okay. Then I can just specify which ports I want to control, and if I want to make those ports as output ports or as input ports. So when I want Raspberry Pi to control outside component, so it will be out. If I want Raspberry Pi to accept input from outside component, so it will be in. In my case, since I'm controlling the motors or the motor of the gate, I need to do like out. So I'll add a broadcast to specify that the port that I'm working on is output, and that is done through adding GPIO, and I should mention the number of the port. In my case, I'll be using port 23, and I'll make it out, and I'll add another broadcast, and I'll specify that GPIO 24. So I'm using only 23 and 24, the ports 23 and 24. Now, by default, we mentioned when we explain the H bridge, and we mentioned that with the L298 and circuit, we can control two motors, and we will be able to control those motors through changing the switches. Like we have two ports, N1 and 2. We'll see that in the wiring part for each of the motor. And now we are using only one part of that circuit, so we need to control those two ports. This is why I specify the port 23 and 24. So for that case, I need to start with all off. I need to turn all the GPIO to false. So I need to put everything as off. So I need to broadcast the GPIO number 23 off, and also the GPIO 24 off. So everything should be off to prevent the motor from beginning to turn in the beginning before like answering any question. Otherwise, the motor might start to turn directly when we run the software. So with that, this is that part that we did is the initiation part. So we're done with the initiation. Now we start our ask. If okay, say that. If not, say that. So it's not only saying I need to do something else. So after the password is okay, if the password is not okay, it's not enough to say that you are not authorized to pass. But what if the password is okay? So what I need to do is to start moving that motor and waiting for 8 seconds, then closing the gate. So the gate will not be opened for a long time, only 8 minutes, and the gate is going to close again. So how to do that? I will also broadcast now. We mentioned that to be able to open the gate, we need to run the motor in one direction. So to be able to run the motor in one direction, so we need to set the GPIO 23 to on and the GPIO 24 to off. And if we want to move in the other way, we need to invest that to make the 23 on and the 24 off. Okay, so let's start by doing that. Let's broadcast. So broadcast the 23 on, 24 on, and the 23 off. Okay, so with that we open the gate. But if we keep that in this way, the motor will keep turning. So we will need to only wait for less than a second, so 0.3 maybe second. Then now to stop the motor again. So to stop the motor again, we need to switch the GPIO 24 to off again. So another broadcast, and the GPIO 24 off again because it was on. Now we open the gate. What we should, all that part is opening the gate and stopping. Now this will go for, as we mentioned, for 8 seconds. After that, the gate should close again. To close the gate, I will copy all that part here So we'll duplicate it to be able to reuse it again. So I will drag all that part here. So we're repeating everything that we did without that wait for 8 seconds. I will remove that wait for 8 seconds. Okay, then what I need to do is just to switch what I did. So if it is on, so here it is off. If it is off, here it is on. Then what was on, we need to switch it off again after 0.3. After that happening, this part ends. We are okay. We're done. Okay. So opening the gate, waiting for 8 seconds, closing the gate. Okay. I'll save that file, save as, and I'll save it as gate. Okay. From that point, we can start wiring our gate to reach the final implementation that we explained. So let's go back to our second camera and try to do the wiring. For our gate example, we will need like a motor, and I used that motor because it has a gear. I took that from one of the old games or old toys that my son has, and it contains only a motor and some small gears. This will make like the movement of the gate slower since we have gears. So if you couldn't find any like gear type of motor, you can use like normal motor, but this will do the same, but you will have very fast speed. So you might not be able to apply the same like kind of functionality. So if you were able to find normal motor, this will show you the how to control the motor, and everything will work fine, but it will not work that slow. So I have like two wires coming from that one, so it will move directly depending on the current direction. So it will move to that direction or that direction depending if the positive, negative poles are changed. So this is the first part, and I attached that like arm to that gear with a couple of screws. We will need the famous L298, and this is the one. Okay. We will need the breadboard. I'm using small one just because I have like limited working space, and of course our famous Raspberry Pi, and I'm using the Raspberry Pi in the black box since I can see those pins here, so no issue for me. So let's start wiring. The first thing that we'll do, I will unplug the Raspberry Pi. So it's very important to unplug the Pi whenever you do any kind of wiring, because this will prevent any kind of accident that might damage your Raspberry Pi. So I'll try to have more focus here just to make that a little bit closer, just to maybe have, yeah, good enough. So let's start with what we are going to do with the Raspberry Pi. So from the Raspberry Pi, we will be having 3 cables. So the first cable is the ground for sure, and I'm using as usual that form here. So So for that, I have 5 volts here. I have the ground, and I have like the GPIO ports. So what I will do is I will use the ground, the 5 volt, just to wire the L298 N, because it needs 5 volt to be working. And I will also use the 2 ports, 23 and 24, for our example. So I will go with wires from those. First I will use, and everything will be going to breadboard, so I will be using like colored wires here. I hope I have the right colors. So for the ground, this will be the third one from the left here. 1, 2, 3. So this is the ground. I will show you that closer. So sorry, 1, 2, 3. This is the ground. So yeah, so I attach that black one to the ground. Now for the 5 volt, since this is like voltage, so I will use something red, and this will be the positive, so I need something red. So where do I have a red cable here? Maybe white will be good, so I'll get the white here. The white also is good enough, and this will go to, this will be wiring the 5 volt in the L298N. Okay, so those two, and I'll need something to go out, which is the those ports that will control the ports, and I will use like this, those two maybe, like the orange and the red one, or I'll use something else. Okay, orange is red are good, and I'll check which one is the 23, 24. As you see here, 23, 24 are this one, 1, 2, 3, 4, 5, 6, 7, 8, and 9. The 8th and the 9th. So I'll count here. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So those will go here. 1 to count double count. This is good. 1, 2, 3, 4, 5, 6, 7, 8, 8, and 9. Those ones. 8 and 9. Okay. Those will be the ports GPIO 23 and 24. Okay. So now I have 4 cables coming out of the Raspberry Pi. Now I'm done with the Raspberry Pi. This is everything that I need to connect to the Raspberry Pi. So as usual, for the ground, this is my breadboard. For the ground, I'll go closer a little bit. For the ground, I'll attach the ground directly to the ground here. Okay, so everything on that, everything I want to ground, I will attach it to that line. Okay. For those two, I will use the number 1, this column here, and this column here, just to be able to attach my other cables. Okay. Okay. Now I need something to go out from here. Now those two will go from here and here, just to extend, nothing else. Like I can just use female and connect those directly, but I'm just extending that to have a taller cables. Okay, so again, the black here is the ground. The black here is the ground coming from the pi, and I'll bring it to that line here. Those two are the ports 23 and 24. I just extend using the breadboard to be like the white and the brown color. Okay, and I have that 5 volt coming directly from the Raspberry. Okay, now let's move to the L298N. So the 5 volt you see here, as you remember when I explained about that circuit, so we have here 3 inputs for like power. The middle one is the ground, so we will get directly a ground and attach it to that one. To do that, let's use that cable here. This is the ground, so I'm just extending that and attaching it to the ground here. So the ground is okay. Now for the 5 volt, you'll notice here that those two has like kind of label here. This one is labeled 5 volt and this one 12 volt. So this one 5 volt and this one 12 volt. For the 5 volt, those 5 volts are responsible of powering the circuit itself, and this should be coming directly from our Raspberry Pi. So I can just connect directly the 5 volt coming from the Raspberry Pi to that one. It's good practice just to test if this is connected like firmly after unscrewing and screwing that. Okay, the next step is to add or wire the source of energy related to the motors. So we said that one of the main purpose of using the L298N is to do the isolation between the source that will be powering the circuit itself and what will be powering the motors. So for the motors, we'll be using separate like source of energy, which will be 2 batteries. So in our case here, I will add only 2 cables, and we will use those cables to directly attached to the motor itself. So what I'll do here is to attach the cable connected to our motor, to the battery of the motor here. So I'll use one red. It's only an extension, no more than that. So this one will be going to the source of electricity, which is the 2 battery. This is the positive. This is the positive. And the negative is coming from the same ground as the Raspberry Pi. So we can take that directly from the breadboard. So I will be attaching another pole here to that breadboard, and those two will be attached to the battery source. Okay. Now, what is the next step? The next step is to wire to attach the wires related to our ports, control ports. So we mentioned that we have 4 control ports here. So 1, 2, 3, 4, and 1 and 2 and 3 and 4. Okay, the 2 on the left are controlling the left motor, and the 2 on the right are controlling the right motor. Okay, so what we will need is only 1 motor, so we will be connecting those 2 only. Okay, the first 2. So I'll be connecting that to the Raspberry Pi port 23 and to the Raspberry Pi port 24. That was extended from here. You remember? We used that to extend those 2. This is 1 and this is 2. Okay. So those 2 will go to the port 23 and 24 on the Raspberry Pi. But we use the breadboard just to make it easier for us. Okay. Next step, wire the motor. This is our motor. We'll make sure that we attach 2 cable to it. I think I have 1 cable escaping here. So what I'll do is reattach that. Just shove it here in a way. Okay, so we have like the cable for the motor. We will attach those here. So now those 2, the yellow and the red coming from here and here, are attaching to the motor itself. The only thing that we're still missing is the source of energy. I will get the source of energy from those 2 batteries here. I don't have battery box, so I'll use this Play-Doh just to create a virtual battery box. So this will be our source of energy. So this is the ground, will go here, and this is the positive pole. The source of the energy will go to this part. Okay, so I think all the levels are done. We need to wire our Raspberry Pi again and try to test our code. Okay, so I'll not be putting that on the gate. The only thing that I'll do, that I'll put that here for you to see if it moves. And the final implementation is the one that I show at the beginning of our work. So we know what we will have at the end, but I'm just repeating that for knowing all the details. So if I go back and try to wire our Raspberry Pi and run it again. Now, wrong password, run, nothing. Right password, run, moving, 8 seconds, 6, 7, 8, going back and stopping, and that's it. So thank you all again, reminding of what we have done here. I'll drag everything to see exactly what we did. So first we have our motor connected to the motor, left motor, okay, on the L2 98N. Then we are having the battery, external battery attached to this and the ground. Okay. We're having the 5 volt coming to power on the L298N from the Raspberry Pi, and using also the same ground coming from the Raspberry Pi. We're having 2 connection attached to N1 and 2 going to our Raspberry Pi through the breadboard and attached directly to the port 23 and 24 on the Raspberry Pi. And as you see, we took the ground from the Raspberry Pi and the 5 volt from the Raspberry Pi. Okay, this was everything for our gate example for today. I know that the layout wasn't perfect, but just trying to do something real and just to give you a hint of some of the application and how reach you can go with having a Raspberry Pi and motor and the L298 and available. So thanks again, and I hope to see you in another video from Logi Owl again. Thank you.